this video, I will be explaining my own solution to the 2024 AMC 10A problem 19. So this problem states, the first three terms of a geometric sequence are the integers a, 720, and b, where a is less than 720, which is less than b. What is the sum of the digits of least possible value of b? Okay, so we have a geometric sequence. All this means is that like we're multiplying by some number. So for example, like the geometric sequence 2, 4, 8, this would just be we're multiplying by 2, 2 times 2 is 4, times 2 is 8. So we're going to do something similar with this problem, right? So we have a, 720, and b in this order of like least to greatest. So let's call like the common number being multiplied c. So we have a, 720, b. We have 720c is equal to b. And then we have ac is equal to 720. And we have this common variable in both equations, c and c. So we can solve for c in both of them and then set them equal to each other, just to get a relationship between a and b. So we have b over 720 equals 720 over a. B over 720 is equal to 720 over a. So b equals 720 squared over a. So let's stop here. Now, what does this tell us, right? To get the least possible value of b, right? That's what the problem's saying. We want the greatest possible value of a. Because think about it, right? If we use, let's say, the number 6, right? Let's say 6 is 720 squared. And a is the denominator. If a were to equal 1, then b would be 6, right? But if a is like a really, like the largest number possible, like say 6, then b would be even smaller, so it would be 1. So as a increases, b decreases. So we want the greatest factor of 720 squared that is less than 720. Like that is all we need to find. So let's see, the greatest factor of 720 squared that is less than 720. That is less than 720. Okay, so how do we find this, right? What I did for this problem is I just did guess and check. So yeah, I can kind of show that process here, right? 720 squared. We can first do prime factorization, so we have 72 squared times 10 squared. This is equal to 9, which is 3 squared, which is 3 to the 4, times 8, 2 to the 6, because it's 2 to the 3 being squared, times 5 squared, times 2 squared. Okay, and then we just do 3 to the 4, times 2 to the 8, times 5 squared. So we have this, right? What I did for this method is I evaluated like each of these numbers being multiplied. So we have 3 to the 4 equals 81, 2 to the 8 equals 256, and 5 squared equals 25. So this just helps in like our guess and check because we can continue dividing each of these powers and multiplying by other numbers. So yeah, let's see. If we take 256, right? If we take 256, so what's like a reasonable number to multiply this by so that we can have a number less than 720? Well, we know 200 times 3 is 600, so that's probably going to be around that range. So we can do 256 times 3. This is 600. 600 plus 150 plus 18. Okay, so then this is 768. That is too large, so we cannot have this. This will not work. Okay, 256 times 2 is just going to be like way too low because we're subtracting. We're going to be in the 500s. So there has to be something larger than that. And if we do 256 times 5, that's going to be way too big because that's going to be in the thousands range. So like 256 cannot be used at all. And so if we move on to 128 maybe. So what can we have for 128? We have, we can do 128 times 5 maybe because this is within range. So we can have 500 plus 100 plus 40, which is 640. This might be the answer, right? Because it's like, it's pretty large, but it's still under 720. So we'll keep an eye on this number. Can we have anything other than 120 times 5? Maybe something slightly larger. If we do 128 times 6, then we're just going to add 128 to 640. That's obviously going to be too large. So like this is all we can have. This is the largest number we can have, involving 128. If we just move down, we're not going to get anything larger than 640. If we move down to like 64, 32, that's not really going to do us any good. So we can just, this is like the largest number in terms of powers of 2, let's assume. And so let's see, what else can we have? Let's take a look at 25 for a second, because we know that 25 squared equals 625, right? So what if we have something slightly larger than 625, maybe being multiplied with 25? Preferably something larger than 640 if we can find something, and it still has to be under 720. So what can that be? Looking at our factors, we have factors of 3, we have factors of 2. That's all we have. So 25 times 26, we can't. 25 times 27 is possible because that's just 3 cubed, right? So 25 times 27 is 625 plus 50. This is 675. And this is larger than 640, so this is the new number that we're going to be looking at. So 640, we don't need to look at this anymore. Let's see, is there any other number which could possibly be larger involving 25? We can have 25 times 28. This would involve a 7, though, which we don't have. That won't work. 25 times 30 is going to be too large. We can't have 25 times 29. So in terms of involving powers of 5, 675 is the largest number we can have. And then we can finally move on to 81. So let's see, 81. What's a reasonable number? Let's see. We can't have any powers of 3. We just have powers of 2 and 5. So if we like literally like 2 times 5, 8, 10. It's way too big. But if we do like something like 81 times 5, that's gonna be too small. So like we're either gonna be too small or too big because we can't have anything in between, right? Because 85 times 5, right? Like that's 405. That's obviously way too small. 81 times 2 is even smaller. And if we put the two numbers together, we get something extremely large. So that's not going to work. In terms of involving powers of 3, we already found 27 times 25. And let's see if we can maybe go down further, but that's just going to give us like 9 times, we can have 25 times 3, which is 75. But that gives us the same thing again, which is 25 times 27. So 675 is our largest factor of 720 squared, which is less than 720. Okay, so that is our value for A, the greatest possible value of A. And that will give us, so 720 squared over 625 is our answer. So we just have to evaluate this now. So 720 squared over 675. We can just simplify this. So we have 72 squared times 10 squared over 675. That is 135 times 5. And this is equal to 9 squared times 8 squared times 5 squared times 2 squared over 135 is 27 times 5, so 27 times 5 squared. 5 squareds cancel out, and we get 3 to the 4 times 2 to the 8 over 3 cubed. And then that cancels out, we have 3. So this is 256 times 3, which is equal to 768. And 7 plus 6 plus 8 equals 21. And so E is our answer. And I know this isn't the most ideal solution because I used a lot of guess and check, but it was just the most intuitive for me because like I knew you can really go above 675 and all the powers and everything. If you want other solutions, you can find them on the AOPS wiki page, but I hope this video helped. Thanks for watching.